Black holes are the most bizarre thing in our universe. So in this video of the cosmos, we are going to answer the questions: how the black hole gets its name and how the black hole forms. So our first question is that how does it get the name as black hole? The physicist John Wheeler is credited with the term black hole. Before him, the idea existed of a star from which not even light could escape, and they have names like dark stars or sometimes frozen stars. Wheeler is renowned for his ability to put complex ideas into simple and very descriptive terms. He is also credited with the word space-time. That is why many physicists agreed with the name black hole. Now come to the second question, that is, how do the black hole form? Black holes are not a normal object that we see in our surrounding. To understand its formation, you have to understand the most general object in our universe, that is a star. As you know, stars are the basic source of energy in the universe, and because of them we can understand the universe more clearly. They are formed from the most basic material, that is matter, which makes up everything in the universe. But in the formation of black holes, we only need massive stars. They must have mass 10 times greater than our sun so that they can form black holes. But why do we need them? Because massive things can create massive objects, that is our black hole. Now I am talking about the fuel of these stars, and when these stars form, they mostly have hydrogen as their fuel, because hydrogen is the most abundant material in the universe. Hydrogen makes up 90% material that is present in the universe, and all the elements heavier than hydrogen makes up only 10% of stuff. Now let's take our sun to understand that how hydrogen is used as fuel in the star. As Sun is approximately 1.3 million times bigger than Earth, the Earth's core is a solid, and we don't need it in our video, so I am eliminating Earth's core in this video. And if you are curious about the Earth's core, you can go in the link in the description below. Now the Sun's core must not be solid like Earth, because there is lot of different things happening there than Earth. The core of the Sun is radioactive, and the state of its core is radioactive plasma, which is very dense and has a very high temperature. Because of that much pressure and temperature in the Sun's core, atoms starts to collide, as the electromagnetic force of the electron and nucleus is not so strong enough to repel the atoms. At that pressure and temperature, there happens a bang between atoms. Because the Sun's core is very dense, the atoms are closely packed and moving at high speeds. Due to temperature and pressure, their probability of hitting each other is too high. And when the atoms collide, they form helium atom, and in the collision 1% of their total energy is released in the form of light. Because stars are pushing atoms opposite to one of the most fundamental forces of nature, which is electromagnetic force, they release so much energy. So in the core of our sun, this reaction is taking place at tremendous rate, which is why we feel the warmth after being that much far from the sun. So these nuclear reactions must be going inside those massive stars, and in those stars the pressure is very high. They must be forming heavier elements than helium in their core, and the heaviest element the most massive stars can form is up to iron, because any star cannot be big enough that it generates so much pressure in the core, due to which iron can fuse. And the star bigger than that are highly unstable. In the core of that star, first layer is of hydrogen, which is fusing into helium. Then comes the helium layer, which is fusing to make carbon and oxygen, and the layer go up to the core where iron is forming. This star also become old. The star energy is getting down because a lot of fuel now starts turning into iron, and the iron core starts to become bigger. When there is no enough fuel left, which works opposite to gravity and stabilizes the star, then the gravity became a major counterpart and starts pushing the star inwards. At this level, the core also starts to become shorter and the density starts increasing very rapidly. A point comes from where the star cannot push it more, therefore a bang happened that we call as supernova. And you must be curious about why this bang happened. You may have heard of Newton's third law of motion. This law tells us that every action has equal and opposite reaction. Now when the core gets too dense that it cannot be pushed to become more dense, it applies an equal and opposite force on the star. which became a supernova explosion. Now during this explosion, elements having the mass greater than iron can be formed, because when the black hole is forming at the core, then there is enough pressure around it that more heavier elements can form. Now the core of the star become a black hole, because it has a radius lower or equal to the Schwarzschild radius, which is the radius that describes that any object must go below that radius to form a black hole, or it will not be too dense to become a black hole if it doesn't fill the Schwarzschild radius. This is how a black hole is formed. So this is the end of this video. Thank you for watching. Please hit the like button and subscribe for more amazing videos. If you haven't watched my previous video, please watch it. Link is in the corner I button and in the description below. You can support me guys by liking and sharing this video.